think we'll now go to the presentation and it is on the agenda. It's the technology demonstration by Border Technology Incorporated. Thank you, Mr. Spencer, for being here today. Looking forward to seeing this presentation.
Thank you, Madam Chairman. Today I'm going to be talking about border technology and a specific kind of technology which we think has hopes for bringing to a final resolution the border problem. Before I get started, I want to talk about kind of the beginnings of border technology. It really started about 13 years ago when I went down and interviewed Muriel Watson down on the border. She was famous for her Light Up the Border project. And she had her friends that lit up the border with cars. And they started out with 24 and ended up with 1,500. And I have this on tape. And by the way, if you saw the recent Outdoor Channel Border Battle segment on me, they featured it. They interview with Muriel and what she really did. It was her action that really led to the construction of the San Diego fence. It was citizen action. And it was at that moment, I have this on tape, I was interviewing Muriel, and I said, gee, you did this with vehicle headlights. Maybe we could use high technology on the border, such as the Internet. And as you can see from that interview, she said, well, that's a good idea. So partly was born the idea of border technology. We got started in 2003, but there's another individual who was very instrumental in this, and he's here. One day, there was a newspaper article about the work I was doing on the border, and I got a call from a young man, and he said, I understand you want to use technology on the border. And I said, yes. And he said, well, I'm your guy. Well, it turns out he was. It turns out he was activated and was in security at Fort Huachuca, had been dragged out there because of 9/11 from Silicon Valley. And he was a computer geek, but he loved Sierra Vista and had been there for a year. And so he came over and we got together. And that was 9 years ago. And he's sitting here today. And his brains are behind most of what he was a sniper, an electronics expert sniper. Of course, the Army was making proper use of its resources once again. But Mike and I have been working together for 9 years. And one of the first things he did, I said, I want to use Internet on the border. And I showed him some fancy slides of all of this expensive stuff that we can use to put the Internet. Next slide, please. And he said, oh, no, you don't need all that fancy stuff. So he went up to the top of my house and dragged the antenna down, got a trailer, put a generator on it, and in 3 days, we were out on the border sending live Internet pictures of people crossing out over the Internet using this contraption that Mike threw together. Next slide, please. Mike also began to develop a battery-operated, these little sensors that were in the ground. Next slide. He designed this circuit so that it would actually have a battery operated, and you put the sensor out, much like the Border Patrol does, out on a trail, and when people walked near it, they would send out a transmitted signal up to a repeater. But what he did was very interesting. Next slide. Instead of people calling off the radio of where this hit, he programmed the computer to send out the information to a beeper. So people were walking along with these beepers, and all of a sudden they would go off and say, sensor 12 has got a hit, 15 hits. So this was a refreshing new idea for border sensors. Next thing. The other major thing that we did was I had said in my plan I wanted to look into the use of unmanned aerial vehicles. So this is, you'll see on the top it says Border Technology, Inc. Those are the people that actually developed this little unmanned aerial vehicle. This was before the Border Patrol ever decided to use them. But next slide, please. This was the complex that we had out in the desert testing this UAV. You'll see an antenna in the back. We were actually flying the UAV along the border, sending the video out over the Internet. Next slide, please. This is the interior of that trailer you saw there. On the right is the moving map display of the guidance system. Mike programmed that from scratch. And also on the left, you'll see a camera. He designed and we developed the world's smallest pan and tilt system that was controlled from the ground. And we can show you a lot of this stuff. We had actually K-Gun out, and we launched it at night. It flew out into the distance. You couldn't see it, went out miles, and was sending out back infrared images out over the Internet. 2 days later, the Border Patrol came out and said, we're going to try these things. And I think any fair observer would say it was Mike King's work, Border Technology's work, to demonstrate that these things work, that led them to develop to use UAVs. Of course, ours cost $50,000. Theirs cost $18 million. Next slide, please. Mike also worked in the development of a very fancy camera system. This was a very expensive camera that we had a big donor that donated a chunk of money. That was $65,000 camera. It was operated over the internet from the ranch down there. It was used to actually, operated by a guy in San Antonio, Texas, a retired Coast Guard captain. We have video on all of that from a story out of a San Antonio station. It's incredible. It worked extremely well. And that's just another example of border technology. Next slide, please. Mike also developed a thermal sensor. Here he is up in the mountains installing it up on Kings Anvil Ranch. But we had a problem with that, and I'll explain that in a minute. Next slide, please. About this time, the need began to arise not only in our minds, but also the Government Accountability Office began to say, you know what we need? The Border Patrol doesn't know how many people are getting away. The RAND Corporation early last year came out with a study and says the Department of Homeland Security does not know how many people are crossing the border. They have no way of knowing. They proposed a few ideas to approach it, but basically said what you need to do is go out and get statistical samples. You have to use some kind of technology to actually sample the people crossing so you can get some numbers. RAND Corporation. Well, what happened next was I had been talking to Mike for some years about work I had done in seismic oil exploration. I actually started up, financed, and ran a seismic oil exploration company. This is some of our equipment. It's called Aerostar. I was the general manager of Aerostar. These are our Vibrasize equipment in North Dakota. By the way, I think some of the data we gathered helped discover a very large resource there near Williston, and I think they used our data. Next picture. Interesting thing about Aerostar was my chief partner was Carl Forstar. Carl Forstar was an Assiniboine Indian, a member of the Fort Peck Indian tribe. And we had another partner who was a Chippewa. And we formed Aerostar. These guys really were the owners. I was the general manager. The guy on the left is from ARCO, and the guy on the right was ARCO. They gave us a great big contract. We found a lot of oil for them. But this was a seismic oil exploration company. Next slide, please. And we were the second largest employer of American Indians in the United States at that time. And I was very proud of the work we did. Here's one of our seismic crews, and what they're holding up in front of you is a string of what we call geophones. These geophones, we would lay out a cable maybe 2 or 3 miles long, and in some cases drill a hole and set off a dynamite charge. And it would give you essentially an underground radar look at the Earth to see where there might be oil traps. So those are those little geophones that they're holding onto there. And when we used to put the geophones out, we have to make sure they were not walking around out there because they had to be quiet. So we would have an oscilloscope, and if anybody was walking, we'd see a little wiggle on the oscilloscope, and we'd have to get on the radio and say, stop it, we're going to make a shot. Well, I kept telling Mike this. I said, years ago, 30 years ago, I ran an oil exploration company using those geophones, and we never really did anything about it. And so finally, with that little last try at some technology, Mike looked at me one day and said, Glenn, I think seismic is the way to go. And I said, Mike, you're right. Next slide, please. I said, let's try it. So what we did is we raised a private fund, and we went out and strung in a half mile of that oil exploration seismic equipment on the ranch down on the border. And then we had to make changes to it. Now, make a little technical point here. The speed of sound in the air is like 700 miles an hour. The speed of sound in the ground is about 8,000 miles an hour. Wow. But what that means is when we do a seismic shot, the sound waves that you set off go down very deep and come back very fast. So you only use the seismic data acquisition for about 15 seconds. So the oil company data acquisition only operated for 15. We needed to operate it 24/7. So major changes were needed. We had to develop an algorithm to process the data to see if this thing could work like I saw 30 years ago, people moving, right? So we had installed it and tested it. Next slide, please. It worked. It worked. We couldn't believe it. We installed this thing, dug a trench, put it in the ground, made the changes, turned it on, and we were picking people up. You know, the ground sensors which we developed were good for about 30 feet, right? 300 feet. 300 feet we were picking people up. We couldn't believe it. And besides that, the oil companies designed these cables to operate everywhere in the world where there's no power. So they're designed to operate off low current. They have battery operated. Well, that was fortunate because all we had to do was stick up a solar panel, and that ran the whole darn thing. So then, not only that, there's a very competitive world out there for all of this equipment, companies competing with each other. So the prices are very reasonable. So we had discovered we have a system for detecting movement along the border that is, you can't see it, operates off solar power, and is cost effective. Next slide, please. So here is the sonic barriers, that's what we call it. Basically, it's buried in the ground. It operates off a solar panel. Right now we have them every quarter of a mile, but we know it'll work every mile. We have a solar panel that is up, operates these sensors in the ground. Next slide, please. Every 5 miles, we have a computer that processes the information and then sends it out over an antenna. Now, one of the things that the problems we have with a lot of the technology on the border is that there are cameras out there, right? And this is high bandwidth. You have to send the video and all of this. This is low bandwidth. All we're doing is sending text. Hey, we found something. We detected something. It's text. It's nothing. So what we do, is show you the next slide, we send the text out to an antenna mounted on a high spot. So every 5 miles, we have an antenna that sends the information up to the internet. So here you have a system operating off of solar panels that is buried, environmentally benign, right? Very good at detecting things, is relatively inexpensive, and can be operated all along on solar panels. Next slide. So there we go. Now, how long can you make it? Now, the problem with the little geophones is that they work for 30 feet. The unique thing about this is they're all connected. You can make this line 2,000 miles long. 2,000 miles long if you want. And it's seamless. You cannot get past any spot on that line. We guarantee it. Now, next slide. Now, people have been down to the border, as some of you, Madam Chairman, and others who are here had been down and actually see some earlier demonstrations. And what you saw was some wiggly lines like that, the sensors going off. Well, we've gone beyond that. And let me explain what was involved in doing that. Next slide. Basically, what we had was this complex electronic equipment in the ground and our computer, which had its algorithm. And we were taking some of the data off of the ground stuff, putting it on a disk, and then running it through our algorithm, and it worked. Next slide. And our algorithm was sort of like a refinery. We're pouring oil through it. It was coming out with detections and so forth. But we didn't have it connected. Go ahead. So we had to actually take the sonic data, store it on a hard drive, next slide, and push it through the refinery. The challenge was now hook up, next slide, hook up the entire data stream or oil field to our algorithm or our refinery. That was a major technical and legal challenge because we had to get the oil field people to agree to let us use their pumps. It was a licensing agreement that we had to work out, their data flow, and it was extremely complex. We have been working on it for months, but we have done it. We got it to work. We got it to work, and it began to work real time out there, real time, half mile. And we began to learning curve. It's better than we thought. It's better than we thought. And it's doing more. And our algorithms are being refined so that we can take advantage that there are multiple sensors. Each sensor is about 240 feet apart, but they're all individually processed in the computer. So you have different things happening to different sensors, and that tells you, is it a vehicle, is it an airplane, is it a tunnel, and so forth. Next slide. So today, we're going to give you a live demonstration of the sonic barrier. And let me go to the next slide. Where it is 100, can we turn the lights down a little over here? Can we dim the lights? Seeing this a little better. Where we are is 180 miles away on the border. Next slide. South of Sierra Vista, you can see Sierra Vista there, the San Pedro River. And now, 5 miles to the east, remember I told you we can send that signal out to an internet connection by wireless? We built one. This is on a ranch out there. The rancher said, great, put it on my place. And there it is. That's our internet connection. And we send the signals wirelessly by 5 miles over to that. And what you're going to see today actually was sent up to the internet over that link. Okay? Next slide. So, Mike King is going to show us a demonstration. What it is, what you're looking at here is the ranch on the border, the sonic barrier a half-mile wide. You see the camera there. There is a camera, an internet-controlled camera, up on a 50-foot mast. Now, this is also wireless. The closest hardwire is 5 miles away. So you're going to be watching an internet camera watch people walk toward the sensor line, and then Mike King is going to come up to you and explain what is happening. Okay? By the way, this is a live view from that camera looking west. That is the fence that they put up on the property after we used our big thermal camera to embarrass them. And that white mark is 300 feet from the line, which is to the right. South is to the left. North is to the right. This is live. You might want to turn that at sort of an angle, Mike. And so that, once again, I'll let Mike take it from here.
Okay, for those of you who don't know me, my name is Michael King. I know several of you. And it's good to see you again. Thank you for letting us be here. Appreciate that. So as Glenn said, what we developed is the sonic barrier. I'm the vice president of border technology. I'm also the program manager for the sonic barrier project. And it did take us quite a while to come up with this, several hurdles that we had to get over in order to get to the point we're at now. And when we first tested this live, like Glenn was saying, we had to shuttle the data back and forth. We had to take it out of the computer that was capturing the data, bring it over to the computer that we could process the data. See, when we first did it live, it was a very exciting day because we knew at that point that we had something that had the potential of securing an entire border of a country with absolute, unbroken, seamless coverage of an area that you want to protect. So what we're going to do now is we have some people staged down by the border, and we're going to have them walk north, heading towards this line. Now, I say they're down by the border. Our line is about 900 feet north of the border. So I can talk to them right here. So, all right, Wes, you guys can go ahead and start walking north, please. Now, what you're going to see on the screen here, you can see that some of our adjacent sensors are going off. So you're seeing this little flashy light here. But this is what a Border Patrol agent would see, or somebody who is monitoring a sensor system would see an overview. And then as that sensor went off, they would be keyed into the location on that border, depending on how big it is, bigger map, of where the sensor's going off. Now, as our group that's walking north progresses, what's going to happen is they're going to trip our sensor. When we start detecting them, it's going to trip. In fact, it just did. And what you're seeing there is a map of where that sensor is going off. The beauty of this system here and the map that you're seeing is that we can move that map around, as you can see on the screen there. Okay, we can zoom in and out, and we can rotate around it and look at it. And what that gives the operator is what is going on right there. We have detected, and now they're more than 300 feet away right now. Now they're just coming. We detected them at over 400 feet from our sensor line. Now, if we had this system placed, say, 25 feet from the border. We can detect them in Mexico before they even attempt to commit to this country, or whatever border that we're trying to protect, before they even try to come into the country. And therefore, a great deterrent is created in this, and it changes the way that we patrol the U.S.-Mexico border. Now, not only does this system detect these people as they walk closer, but it also counts them. Now, currently, our counting system is not online, unfortunately. It will be. We just couldn't get it done in time for this demonstration.
To that point.
Yes, we just couldn't get it to that.
To radio, to have them wave to us.
Yes, certainly. Wes, I want you guys to stop, and I want you all to wave at us right now.
Great.
Thank you, sir. Continue walking. Okay. So what you've done, and you can see at the, let's see here, I'll show you down at the bottom here because it's very interesting. You see how it says inactive right now? Oh, yeah. Continue walking north. Notice at the bottom down here, it says inactive, right here. As it detects them again, it will go active. And that's why we know that they're still in the detection zone. Now, as they continue to walk forward, as soon as they reach the line, that's when our counting takes place. Now, let's say if we had this on the U.S.-Mexico border and we counted every single person that attempted to enter this country, well, then we have a figure of merit. And then we can find out exactly how good our U.S. government is doing in protecting our border at that point. And that was the whole purpose of having a sensor system this accurate and this powerful with this kind of range.
You want them to stop at the line?
Yeah. Barely getting signal here on this. When you guys get to the border, stop and hold still. You know, watch the active symbol here.
Okay, so Mike, we're the active symbol. They haven't reached the 300-foot mark yet. Is that?
They passed
so what are we looking at the active symbol? What's that?
Because they stopped walking, we're no longer detecting people walking at this point. And that's what that's demonstrating. So it gives the operator an idea, okay, are we still detecting? Because we're not going to make the map go away,
Yeah.
But we want to make it so that they know that they're still in detection. We detected them in this particular test at over 400 feet from our sensor line, which is just phenomenal. This kind of sensor is, according to our research, we have not found anything in the whole world that has this kind of detection range with seismic, and that can discriminate like this.
And Madam
Tell
Chair,
if it's-
Mike, that's just all on the geophones then.
That is just all
So
on geophones.
is it possible to create or build or install a more powerful geophone, and then you can go to 500, 600, 700 feet?
Well, the reason our detection ranges are 300 feet is not because we're not detecting them out that far. It's because our analytics are, as we progress in this, our analytics will get better. And as our analytics get better, our detection ranges will get greater.
Okay.
Is basically what it is. Right now, we say 300 feet, but as you can see, it detected it quite a bit farther. That white poster board that we were first looking at was actually our 300-foot mark. So we know where 300 feet is because that was our benchmark. We needed to beat that. We needed to make sure this thing made a bunch of noise before they were passing that. And we did that, and now it's gone further.
Mike, can you put these type of equipment in a car so that the car would be able to pick up somehow the barriers going off?
Or
does
you
it
mean
have to
give
be
the ability for the people out there to have the ability to have detection capability, so they're able to monitor the sensor line? Is that what you mean?
Yeah, what I mean is, you would be monitoring this in a building, but could you also have cars that are monitoring it?
Yes.
Or could the building send the information to cars or vehicles that could then go to that part of the border or that part of the map?
Absolutely, and that's something that is commonly done and very easy to implement. It's not something that we would be perplexed with. You guys did a great job.
Senator Melvin.
Madam Chairman, we have several command centers in Arizona that could potentially be used by us in this effort to secure the border. There's one or two in the Tucson area. There are a couple up here in Phoenix. So just like we're seeing this today, this information could be relayed to a command center to the north where we could be looking at it 24 hours a day.
Yes. In fact, I could take you and me could go to a coffee shop right now with this laptop and monitor the border.
Okay. And then, as Madam Chairman said, then you could dispatch people to.
Yes, and that's why we gave them the ability to have a map, so they can get an idea what the terrain is. Because you're going to look at this, and somebody who has any training on the border whatsoever say, oh, well, there's a trail there, and there's also a wash. So they might be heading into that wash. Okay, guys, you need to go over there. There's a wash there, and be able to kind of give them a heads up of what they're going to run into when they get there.
Adam, Madam Chairman, and is this, we were talking a little bit before the committee meeting started, is the sensor we're talking about the one, like,
Yes,
the
the
size
cable's
of a
about as thick
finger,
as my finger right here.
buried about,
And it's buried about between 12 to 18 inches, depending on how secure you want it to be. If you have an area where you know people might be trying to dig it up, you could put it down 10 feet. It wouldn't matter. We could still detect them there.
and, Madam Chairman, so not only on the border, but you mentioned King Anvil Ranch.
King Anvil Ranch?
Or like south of I-8. We know there's a staging area there. You could put it anywhere.
Also the Ladd Ranch, just east of us also.
Yeah.
Yeah, absolutely.
Okay.
It's environmentally benign, as Glenn said. You put it in the ground, and it's just, you don't see it. In fact, if you went out where it's buried now, you would, if you didn't know it was there, you wouldn't be able to find it. You wouldn't know. You wouldn't be able to find it.
Mike, how expensive is this going to be? Just give us a rough estimate of what it would be per mile.
I'll defer to Glenn on that.
Come back to
We
the
have been working
podium.
on this.
Come back to the podium so the mic picks you up, please, Glenn. Thank you.
Our first number that we came up with when we were discussing this was between $50,000 and $70,000 a mile. Now, Boeing spent $17 million a mile on the virtual fence system. However, what we have learned in working with this thing is it's better than we thought, but there are things that need to be done when it's installed to tailor make it to the site. Since each sensor is calibrated individually, it needs to be done when it's installed. So installation has to be done very carefully to calibrate it. That, and also some hardware changes which are already designed have to be made to take advantage, as we learned, when you've got multiple sensors out there. Instead of just looking at the data from one, you look at from all of them simultaneously and correlate what's going on. Now, this has added to the cost. To do all of these things, to install it properly. We thought we'd just go out and install it. Not a good idea. The sound travels, as I say, about 8,000 miles an hour in the ground. We've got things like P waves, S waves, Raleigh waves, different conditions. To optimize it, it really needs to be tailor-made, put in the ground, and then turnkeyed, right? Okay, you've got it, it's working perfectly, and nothing should change. So we're thinking now a target solid figure of about $100,000 a mile, installed, turnkeyed, operating, reliable, and guaranteed.
$100,000?
$100,000 a mile. Now, this is new equipment. This is different. This is not what, this is manufactured especially for this application. It won't run, you can't find oil with it. It's got its own software. It's got its own cables, okay, that are different. But all of this is it can be manufactured fairly in a very straightforward way. But what we've learned in using it is to make it works better than we thought. It's more capable, but it's going to require more to get it installed.
Let's see, another question. How many acres of private land do we have along the border? I can't remember, I've been told, but do you have any idea?
Well, there's a lot of private land, but there's private land in private land. One of the most sensitive areas right now is east of Douglas, and I've taken some people flying over there. There is about 12 miles of private land, but it's owned by the Nature Conservancy. And I don't believe they'll let anybody on there. Now, there's still always the 60-foot, what they call a Roosevelt easement on the U.S. border. So the first 60 foot of that border, by order of Teddy Roosevelt, is owned by the federal government. By the way, they only missed one little spot on the whole border. Guess who owned it? I did. It's just a funny story. Anyway, there's 60 feet. This can be installed in nothing, okay? So you can install this in that 60-foot easement all along the border with no problems as far as ownership of property is concerned.
Madam Chair.
Yeah.
Mr. Spencer, to that point, I've heard conflicting reports about tribal land and the 60-foot easement. The federal government, correct me if I'm wrong, the entire border, unabridged, that 60-foot is the federal government's property, even when running through tribal land. Is that true?
That's what I was told when they.
Even when it runs through the TO Nation that goes north and south, that 60-foot is ours.
And this is one of the reasons that you see on that easement, all of those vehicle barriers built in there. They did not have to get permission from the tribe to build those things in there. I think it would have been a political issue had they had to do that. But I'm not a lawyer, but I can't give you an opinion, but that's what I've been told and that's what I've observed.
Well, another question?
Well, I just have questions in general, Madam Chair,
Okay.
if you've yielded the floor.
Yes, well, go ahead, and then Senator Melvin after you.
Okay, well, let me start off by saying to Mike and Glenn, I want to echo the comments of Senator Allen. I appreciate the work that both of you have done tirelessly, thanklessly, and I just want to personally say thank you for the work you're doing. And it's a shame that a few rogue liberal opinions can taint an otherwise seemingly productive career from the both of you. So thank you for taking the time and doing this. But more importantly, I want to thank you for everything you've done on the border, which I know is extensive. That being said, a couple quick questions, points of clarifications. I know for certain this technology can detect the difference between animals, vehicles, ultralights, tunneling. Can you just kind of get into that a little bit, what the screen would look like? Would the sensor make a different noise if it was a truck as opposed to a human, as opposed to a deer, as opposed to something walking underground tunneling? And how would a Border Patrol agent or anybody looking at the map, when they see something coming on the screen, I guess if the camera didn't get them, would they assume they're underground in a tunnel?
I was about to ask Mike King to come up and address that, but he's here.
That's right.
Well, basically, the whole thing is that the data we're getting so much data that we're only using a small fraction of the data that we're actually capturing right now. And as this moves forward, we had to just draw a line somewhere and say, okay, stop development. We got to move, because we're going to run out of money. We could develop forever. We're just not going to have any money left. So we said we have to stop development at some point. So we stopped development, basically saying, okay, our goal right now, we need to detect humans and we need to detect vehicles. Those are the two things that were really big deals, okay? So we created this system to do that. Now, with the amount of data that we're actually capturing, though, we feel very strongly that it will yield to analytical pressure. So we could really, really, really take this next level. Now, if you have somebody tunneling under a border, well, they still have to walk. We'll detect them. If they go out there and looking around and they're still detecting somebody walking, they're probably under them. But we can, again, the analytical pressure of looking at, well, how do people tunnel? What kind of tools do they use when they're tunneling? Things like that, so that we can then run that kind of data through our algorithms and say, okay, how do we detect this now?
To that point, yes.
Yes.
Because they're going to make noise while they're digging that tunnel, and that is going to send those sensors off.
Yes, absolutely.
And maybe it isn't going to be the same pattern that you know when a person is doing actual walking, but it would at least tip you off.
Oh, yeah.
Some sort of noise is going on over there, some sort of activity.
Yeah, you are not going to tunnel under this thing without being detected.
Right.
Well, Madam Chair, and to that point, many of the tunnels are already built. So
You would detect them walking.
yes.
Yeah.
So yes.
You can't. This thing is extraordinarily sensitive. I had one of my guys out there for a test try to tiptoe across this line. I said, as quiet as you can. I don't care how long it takes you. Just do it. And as soon as he got, now granted, his seismic signature wasn't as great, but as he got close to the line, it wasn't a stretch to see him. It was huge. Huge. What you cannot sneak across this line. You can't tunnel under it. You can't tiptoe across it. And if you're low-flying aircraft, we're going to detect you. If you're a helicopter, we're going to detect you. If you're an ultralight, we're going to detect you.
And Madam Chair, now the 300 foot, though, when you're And an ultralight,
That's 300 foot for a human walking.
right.
An ultralight with a big loud noise could be,
But it'll come and go on your screen like that, though, wouldn't it? Because it would just go, whoop, and there it is, and it's gone.
yes.
So if
But we
one
could,
were
we could
looking
give
at
somebody
it,
an idea
they
of
might
where
look
they're
at it as,
crossing.
okay.
Yeah,
Yes.
it has to go back too. Okay, so if you come in and you detect it crossing the border, what they typically do is drop their drug load. Okay, they typically drop their drug load and then turn around and hit south. So if you take the time they went across, and when they came back, you pretty well know where they dropped their load. You know how fast they went.
Madam Chair, does this pick up rate of movement? So would you be able to see something, oh, something went overhead at, right?
Nah, the problem is
100
that
miles an hour?
altitude. See, the thing is, it's relative to how far away they are, how loud they are, what muffler they're using, you know, that kind of thing. So I can't tell you how fast they're going. No.
Okay. Madam
But
Chair,
I bet they're going as fast as they can.
of course they are. Mike, now you talked about the seismic footprint. So if it was a deer, if it was any other animal, that would make a different noise or not pick it up at all?
What we're striving to find, well, okay, I need to digress a little bit to make you guys understand the difficulties we actually ran into in developing this sensor. We went out and looked for all the human algorithms that were currently in existence, and it got into really thick math, really thick stuff. But the one thing that we didn't take into consideration when we were looking at that is the sensors that they were using had a detection range of 15 feet, okay? And in 15 feet, you may be able to have 2 or 3 people walking in a line going by. So the math that they used was very effective for that. Now, our sensors picked up things at 300 feet. We could have 100 people walking in a line. And that made it very difficult because now their math formulas didn't work anymore. So we went into uncharted territory. So we had to look more specifically at not so much as, see, if anybody tells you their sensors will differentiate a horse from a human, then they're lying to you. If anybody tells you that it'll detect a cow from a human, they're lying to you. What we found is not so much how the seismic signature is different, but how the animal behaves. Humans have a focus, they walk, and they go, and they go, and they go, versus animals tend to move, stop, move, stop, move, stop, move, stop. But that doesn't keep us from alerting, because if that's the only false positive we get, if we detect a group of cows out there walking, and we send an agent out, and he goes, it's cows. If that's the worst thing that they have to deal with, that's not that bad. The radar systems they currently use had them chasing rabbits, often. So with this system, and the other thing we found too is that with the experience of using this thing, we found that the length of time that the detection is happening tends to tell us a lot more about the group and gives us weight as to if it's a human detection or not.
And may I just jump in there? Most of the border has either a fence or a vehicle barrier. Cows aren't going to go across there. Cows are not going to walk up to that vehicle barrier in a straight line and crawl across it. They're not even going to come close. So for most of the border, that is not a problem. But what as Mike is saying is, instead of people looking at 2-3 seconds worth of data, we're looking at 2.5 minutes. So our algorithms can get more accurate as they get closer. We can say those are humans. No animal is going to do that. But once again, you can protect against that by better process.
Yeah.
And that's why we also brought a camera to bear on this, is so that we can verify that our hits are general.
Madam Chair, so that's the next quick question. So when you get, let's say this is strung along 10 miles of the border, and on a random night you get a group of 20 walking at mile marker 1 and a group of 15 at mile marker 1.3 and a group of 9 at mile marker 7, all at the same time. How does the camera react? Because it's a camera for every 5 miles. Is that correct? And how does the screen react? Is it just kind of buttons and bleeps overkill, or does it accurately pick up, like you said, the exact number and the exact quadrant on the exact area?
I'm going to let this thing go nuts on you here. I'm just going to let it hit. Okay. We have a sensor. Our sensor 3 is runs right through our office. There's people walking around down there. Okay, so that one tends to go off all the time. This thing could bring up multiple screens. As you can see, this screen right here is the map screen we're currently using. It will bring up multiple screens of the same thing, and you can process multiple hits at the same time. We have a very small monitor here to show you guys this on. I apologize that we couldn't bring some massive thing, but that's what I would give the person monitoring this so that he could have and work multiple hits at the same time.
So, Madam Chair, that was my question. So clearly, I know you've thought this out.
As far as the camera is concerned, I would have presets on the camera that allow me to swing around to individual sensors. But I don't think I would take the camera's operation necessarily away from the agent, because he still needs to get on it and actually locate what's there and then be able to follow them and to help direct agents and stuff, or whoever's going to be securing that area.
So, Mike, if there were multiple crossing points happening, would that camera by itself, when it detected, turn and swing and view it, or does the operator turn and swing?
I would probably give him a button right here on the screen that said, click here to swing over and look.
This camera is not part of this system.
This is just our system.
Demonstrate. This is not incorporated into the $100,000 a mile. If I may say, Mike, let me just talk about that. We have installed cameras. We have done aerial surveillance. We have done, for 10 years, we've been on the border, flying at technology. The major problem you have with most of these technologies, including the UAVs, including the Predator, is you don't know where to point the thing, okay? The Predator right now is an extremely big waste of money. With this system installed, it would become more cost effective. Cameras, people sitting there looking around, are usually a big waste of time and money because they get fatigued. They keep looking for something that never shows up. So the whole problem on the border is knowing when and where to look to focus your attention. That's what this does. It makes every tool they have on the border 3 to 4 times more cost effective in my judgment.
So, Madam Chair, Glenn, would you not want to implement a camera system with this technology, or is it just maybe make it more expensive, so we're just looking at this piece?
No, we want to have this standalone, then people can say, well, I want to use a camera. No, I want to use a UAV, okay? No, I want to use a balloon or something else. So
But you clearly could put a camera on it.
We could put a camera on it.
We could interface with what they currently have just as easily.
Okay,
Yeah,
Madam Chair, one last question.
Okay.
Rivers. How do we? How would you detect something if somebody was walking in a shallow river?
We have already addressed this. We actually run the sensor line up the river. Turn the corner and have it run up the river, so anything that's in the river we can detect out there.
Okay.
So if it's in the river, would have to be over 600 feet wide for us to. So I think we're good in Arizona.
Well, so that's all for me, Matt. Thank you again very much. Yeah.
This is very fascinating. I've really enjoyed learning about this and the previous times I've visited up there. I think this really is something that's possible, and it's, of course, as far as expense, some of the things that we've looked at, and it certainly is in the ball field much better. Senator Melvin, you wanted to...
Madam Chairman, a couple of things. One, I want to thank Senator Smith again. We've got this website up and running called buildtheborderfence.com. I think we've raised about $300,000 or so. And we need to raise more, but you've got a PR company, I believe, working on that to raise more money. And with that in mind, we've talked about building a fence, but I think to be cost effective, we can use this technology, to use the physical fence or this. And along those lines, I don't know how much it would bring the cost down, but we've talked about using inmate labor at 50 cents an hour to at least do the physical, the digging and dropping it into the trench and then covering it up. Maybe that could...
Glenn and I have talked extensively about this, and it does take a professional out there to make sure that this is in the ground properly. Now, as far as digging a hole are concerned, we might be able to work with you on that type of thing. But as far as the installation process itself, it is making sure that everything's in the ground, is sealed and everything like that, and then running the putting the dirt on top of it, running the calibration process. It's
Yeah.
an extensive process, step by step, has to be done.
But I think it's that manual labor part that we can save a little bit of money with the inmate labor. And then finally, the last thing is, for the camera, for the people in the room, this show that took place here prior to you coming up to the podium, it is truly sad, where two Arizona state senators would remove themselves from the room when here we have two patriotic Americans who are trying to help the state secure the border, and there are entities trying to intimidate you from doing your patriotic work. It's truly sad. But I want to commend the Madam Chairman for continuing on to allow these two to present to us. And I applaud your hard work that you've done here. You've taken your God-given talents and you've brought them before us. And I, for one, want to do everything we can to take full advantage of what you're offering us to secure the border. Thank you.
Thank you.
Thank you very much.
Can I say something in Glenn's
Yes. Yes.
behalf? I have worked with Glenn for 10 years on the border. Never once has this man alluded to being a racist or anything like that. And I just don't know where this stuff comes from. It just boggles my mind. We have Mexicans in our employment. You know, it just doesn't make sense that they talk this way. Glenn is not a mean person, and he's not a racist, and he doesn't hate Jewish people. So it boggles my mind that this stuff comes out. For 10 years, never.
Well, it's,
One point.
it's, Glenn,
Would
Glenn,
we
go
be
up to the
willing-
mic.
Okay, go ahead.
Up to the mic,
Oh,
please, Glenn.
What the state might be interested in is having a independent technical assessment, some expert come down to the border and say, all right, this is a test I would like to run, and to evaluate this, the effectiveness of this. We've had other technical companies who are interested in maybe joining in with us on proposals in the future, sent engineers and electronics experts down and looked at this. They're very impressed and signed non-disclosure agreements with us. So they